this module, you will learn about change of state and latent heat. Matter exists in three states: solids, liquids, and gases. The transition of matter from one state to another is called change of state. The change of state from solid to liquid is called melting. And from liquid to solid, it is called fusion. A change of state from liquid to gas is called boiling or vaporization. And from gas to liquid is called condensation. Consider a round bottom flask with a thermometer and steam outlet fixed through the cork. Place some ice cubes at -10 degrees centigrade in the flask and start heating. Now, let us observe the change in the temperature of the contents and plot a graph between temperature along the y-axis and time along the x-axis, as it is an independent quantity. Initially, we observe a rise in the temperature of the ice as it absorbs heat energy. This continues till the ice attains a temperature of 0 degrees Celsius. If we continue heating the flask, strangely, we don't observe any rise in the temperature in the ice cubes. But we can observe some of the ice cubes melting. This indicates the change of state of ice to water. And during this process, both solid ice and liquid water coexist. No change in the temperature is observed till the entire ice in the flask melts to water. That means, on absorbing heat, ice at 0 degrees Celsius converts to water at 0 degrees Celsius. The temperature at which the solid and liquid states of a substance are in thermal equilibrium with each other is called melting point. Thus, the melting point of ice is 0 degrees Celsius. In this case, the heat supplied is utilized to increase the internal energy of the substance. The amount of heat absorbed by a unit mass of a substance to convert it completely from one state to another state is called latent heat, usually denoted by L. The word latent means hidden and is derived from the Latin root word latentum, which means to lie hidden. Latent heat is a characteristic of the substance. If Q is the heat required to convert a substance of mass m completely from one state to another at a constant temperature, then Q is equal to the product of M and L, where L is the latent heat of the substance for that particular change of state. The latent heat in the case of solid to liquid transition is called latent heat of fusion, denoted by LF. If we continue heating the water in the flask, its temperature starts rising again and continues to rise to 100 degrees Celsius. As the water gets heated, first, the air that is dissolved in water forms small bubbles at the bottom of the container. After some time, steam bubbles form at the bottom of the flask and move upwards. As they reach the cooler water at the top, they condense and disappear. The process of bubbles of steam forming and reaching the surface intensifies, and we say that the water is boiling. At this point, once again we observe no change in the temperature of the water, even though the water changes to water vapor. Even if we continue heating, the temperature of the water remains constant, and the heat absorbed is used to change the state from liquid to gaseous state. The constant temperature at which the liquid and the vapor states of a substance coexist is called boiling point. The heat required to convert 1 unit mass of a substance completely from the liquid to gaseous state at its boiling point is called latent heat of vaporization and is denoted by LV. If the rate of heat supplied by the source is known, a temperature time graph can be converted into a temperature heat graph, which is usually called a heating curve. Some parts of the curve are parallel to the x-axis, and some of them are inclined. The inclined portions of the graph correspond to a particular state of the substance. The slopes of the inclined portions are not equal. This means a substance will have different specific heat capacities in different states. The temperatures corresponding to parallel portions of the graph correspond to melting and boiling points. The melting point and boiling point of a substance depends on pressure. If measured at standard atmospheric pressure, they are called normal melting point and normal boiling point. For example, the melting point of ice decreases with an increase in pressure. If a metallic wire with 2 masses tied to both ends is placed on a slab of ice, we observe it passing through the slab. As the wire exerts pressure, the ice beneath it melts. When the wire passes through, the water above the wire freezes once again. This phenomenon of refreezing is called regulation. In fact, ice skating is possible only because of regulation. When the skaters move on ice, due to the sharp wedges at the bottom of the skates, there is an increase in pressure on the ice, and due to this, the ice beneath melts below its normal melting point. This makes the motion of the skaters smooth and friction-free. The boiling point of water increases with an increase in pressure. To understand this, let us return to the experiment where water was heated in a round-bottomed flask. When the steam outlet is closed, the pressure inside the flask increases, and the boiling point of water also increases. Therefore, the water in the flask stops boiling after some time. After absorbing more heat, the temperature of the water increases to a new boiling point, and it starts boiling again. A pressure cooker works on this principle. When food is cooked in a pressure cooker, The pressure that builds in the cooker increases the boiling point of water to higher than normal. And the food in the cooker is cooked at a higher temperature than if it were cooked outside. This makes cooking quicker and cost-effective. Cooking is difficult in hill stations because at high altitudes, the atmospheric pressure is lower than normal. And as a result, the boiling point of water decreases. Usually, on heating, substances change from solid to liquid and then from liquid to gaseous state. There are certain substances which change from the solid to gaseous state directly. This phenomenon of changing directly from the solid to gaseous state is called sublimation. Dry ice and iodine are some examples of such substances. You have now reached the end of this module. In this module, you learnt that transition of matter from one state to another is called change of state. The change of state from solid to liquid is called melting. The change of state from liquid to solid is called fusion. The change of state from liquid to gaseous state is called boiling or vaporization. The change of state from gaseous state to liquid is called condensation. The temperature at which the solid and liquid states of a substance are in thermal equilibrium with each other is called the melting point. The amount of heat absorbed by a unit mass of a substance to convert it completely from one state to another state is called latent heat, L. The latent heat absorbed in the case of solid to liquid transition is called latent heat of fusion, LF. The constant temperature at which the liquid and the vapor states of a substance coexist is called boiling point. The heat required to convert one unit mass of a substance completely from the liquid to gaseous state is called latent heat of vaporization, LV.